we'll just have to see this time around. But yeah, I don't know what's happening. I really don't know what's happening. Anyways, in the diagram, FG is perpendicular to GH. Find the value of X. Now, in order to find the value of X, what do we see? So on this here, we have HG, which is basically a straight line. So we have a straight line here. And on this straight line, we have angles. So we have this angle that goes from the straight line up until this line that we have here. Okay, we call this angle 2x minus 9 degrees. Then we have this angle that follows after 2x minus 9 degrees, which is angle x. And then we have this angle from here all the way back to the straight line, and we have this 90-degree angle. So this little box here stands for 90 degrees. So basically 2x minus 9 degrees all the way to this line up until this little space here, we have x, and then we take this from this angle all the way to this line. So basically there's something that you should observe from this. You should observe that from here, this line, this straight line, up until here, okay, that's 2x minus 9 degrees. And then from here up until the x, that's x degrees. And then from here all the way back to the straight line, all right, we have this 90 degrees. Now all of these angles added together should give us a whooping what? 180 degrees. That's why we refer to these angles as angles on a straight line. We call them adjacent angles, and they are all lying on the straight line. Now if we can clearly see that from here, the straight line, to this angle, which is 2x minus 9 degrees, from here to x, which is x degrees, and then from here up until the very end here, this 90 degrees. This completes the straight line. Then we can basically say that these respective angles added together, they give us 180 degrees. All right. Snowtick, TK. Hello, sorry, you helped me a lot. Everything you taught me was in the paper, and I'm done writing. Oh, that's great. I'm happy for you. Good job, Snow TK. I'm glad that the live lessons helped. Guys, there's a likelihood that I may get restricted by TikTok. That's what's happening lately. I don't know why, but if that does happen, I'm going to move over to my YouTube channel and I'm going to do a live there, and I'm going to continue with this because there's apparently restrictions that basically are limiting me here, and I don't know why. But we'll go as far as we can and we'll see how far we can go. No, this is just a paper. This is a grade 9 maths, okay, paper 2. So 2x minus 9 degrees right, so sorry, we're back. So like I was explaining here, we have 2x minus 9 degrees, we have x, we have 90 degrees. We are being told in the diagram FG is perpendicular to GH. Now this here should say something to you. Where's FG? FG is from here up until there. That's FG, that's the line FG. When they say perpendicular to GH, immediately what comes to you is the fact that FG, this angle that's here, is 90 degrees. It also stands to reason that this angle as well, this side, is also 90 degrees. That's what FG, this symbol here, this upside down T, means perpendicular. And perpendicular simply means that the angle where the two lines actually meet, the angles that are formed are 90 and 90 degrees respectively. All right, so what we can then do is, like I said, 2x minus 9 degrees from here, from this line up until here. Then from here, from this point to here, we have x degree, the x angle. Then from here up until back to the straight line, we have 90 degrees. So what we can simply then do here is we can say 2x minus 9 degrees plus the x plus the 90 degrees is equal to 180 degrees. All right, 180 degrees. That's what you're looking for. So what is the reason? The reason is because we say these are angles on a straight line. Okay, angles on a straight line. And it's very important that we give our reason. Okay, very important. So 2x minus 9 degrees plus x plus 90 degrees is equal to 180 degrees. We know that angles that lie on a straight line, and remember, these angles need to complete the straight line. It's almost as if you could actually place your protractor. This is actually shaped in the protractor sort of like shape. All right, so that's why we say this angle plus this angle plus this angle is equal to 180 degrees. The reason is because angles on a straight line. Okay, then all we need to do is solve for x from here. So we have 2x plus x. So we isolate the x's on one side, and then we take the angles, the numerical angles, and we transpose them onto the right hand side. So plus 90 becomes minus 90, and then minus 9 becomes plus 9, okay, degrees. Okay, and then all we do is we say 2x plus x, that gives us 3x. Then all we do is we actually add the angle. So here we have 180 minus 90, which is 90. And then 90 plus 9 gives us a 99 degrees. And then obviously when we solve for x, what do? We take on each side, we divide by the coefficient of x if that is present. So we divide both sides by 3. And then we get a nice answer of what? Of 33 degrees. Okay. Remember, I may be late for you, but I'm not late for those who are actually writing tomorrow, which is Friday. Okay, that's fine if you're done with the exams, and I'm very happy for you. Hopefully you did well, and you did phenomenally well. That's very important that you are able to do so. Okay, remember that I'm late for those who wrote, but I'm not late for those who are writing tomorrow. Okay, so 1.2, in the diagram below, AB is parallel to CD. So where's AB? This is AB. Where's CD? That's CD. And what are we learning? That AB is parallel to CD. Okay, M is equal to 110 degrees. Where's M? Angle M. Okay, that is angle M is equal to 110 degrees. So this is this angle here. Okay, and we are told that CEG. Now, very important. This thing here of CEG, remember the middle letter represents the angle we are speaking about. So we move in this fashion, CEG. So that means this angle here, this angle. Okay, so once again, CEG, the middle letter represents the angle. CEG is equal to what? 2p plus 30 degrees. So this entire angle is equal to 2p plus 30 degrees. Then they are saying calculate the what? The size of p. All right. Now remember, we are told that M is equal to 110 degrees. So we are actually given, even though in the diagram we have the letter, in our statement, if you don't read the statement and actually take what you're supposed to take from the statement, angle M is 110. So that means this is actually 110 degrees. So now we are supposed to calculate what? Calculate the size of P. Now where is P? P is part of this angle here, which is CEG. What relationship exists between the angles that you have been given, meaning this angle 2P plus 30 degrees and your angle M, which is 110 degrees? What angle relationship exists between these two parallel lines? The position of M and the position of 2P plus 30. What is the relationship that we refer to that exists between these two angles since they are parallel lines? So hopefully we all know that there are three relationships that exist between parallel lines. Okay, and these three relationships that exist between parallel lines, we have corresponding angles, which we call that the F relationship. I usually say that it's like your bottom of one parallel line, and at the bottom of the other parallel line, we say that those angles are actually corresponding. Or we can say on top of the one parallel line, if there's an angle, and then on top of the other parallel line, we refer to those angles also as corresponding. So it's like bottom, bottom, corresponding, or we can say on top, those are corresponding. That's the F relationship for parallel lines. Or you can have the U relationship. The U relationship has, we call those angles co-interior angles. Okay, co-interior angles. Okay, yeah. So it's very important that we understand. I usually say co-interior angles are like the angles on your armpits. So in other words, if you extend your two arms in front of you, and then you basically look at your the position where your armpits are, those would be co-interior angles. And what about co-interior angles? The sum of those angles actually equals to 180. The angles are not equal, but the sum of those angles gives you 180 degrees. So those are co-interior angles, the U relationship, or sometimes they usually say it's the C relationship. Okay, those angles are not equal, but the sum of those angles, the angles in your armpits, they add up to 180 degrees. And then lastly, there's the Z relationship. Those we refer to as the alternate angles. The angles that are formed by your Z relationship are actually equal. Okay, so corresponding angles, your F relationship, on top, bottom, bottom, those angles are equal. Your Z relationship, your alternate angles, those angles are also what? They are equal. Whether it's your Z that is like your proper shape, but then there's the Z that basically is an improper Z shape. That is also representative of alternate angles. So we have corresponding angles, F relationship, okay? On bottom, the angles are equal, or top, the angles are equal. That's for your F relationship. Those are corresponding angles. If the lines are parallel, then your corresponding angles are equal. Then we have co-interior angles, angles in your armpits. When you add those angles, they add up to 180 degrees. They are not equal. Then you have your Z relationship, which are your alternate angles. Those angles are also what? They are equal as well. So that's very important. Then obviously there's the X. Those are not parallel lines for parallel lines, but those are angles that exist between two intersecting lines. And usually there's the X relationship. We say that the angles, this angle and this angle is equal, vertically opposite angle. And we usually say this angle and this angle are also equal, vertically opposite angles. So it's very important. So I repeat, F, bottom of the parallel lines, we say that those angles are corresponding angles. They are equal if the lines are parallel. Then we have what? We have co-interior angles. Co-interior angles, those are angles, the angles at your armpits. We say that the sum of those angles, if you add them together, we can actually get 180 degrees. Then we have your Z relationship. Those are alternate angles. We say that those angles are also equal if the lines are parallel, and those are the angles situated basically where you can see the crevices of your Z, basically N and Z. Very, very important. Okay, then like I said, you have the X there, which we refer to as the vertically opposite angles. And I like that someone else actually mentioned that there's revolution angles, and that's very important because remember, revolution angles have to do with angles around a specific point. So the full circle from here to here, from there to there, from there to there, all the way back to where we started, if we look at the sum of all those angles, they add up to 360 degrees. So let's come back here, because we only diverted to an explanation of these because we need that information and that understanding to be able to go ahead and answer this question. So in the diagram below, as it says AB is parallel to CD. Angle M is 110. So that 110 was not in the diagram. So what we did is we actually we filled in the 110 in our diagram so that we can see it. Then it says angle CEG, all right, is equal to 2p plus what? Plus 30 degrees. 2p plus 30 degrees. There we have it. 2p plus 30 degrees. Then we are asked to calculate the what? The size of angle P. So here we can see clearly that angle P and this angle M have a relationship. What sort of relationship do they have? I'm sure we can see it. This is bottom of this parallel line on the same side of the transversal line, and it's bottom of this parallel line on the same side. That means these two angles are corresponding, and they are therefore what? They are equal. So what we do is we take the 2p plus 30 degrees and we simply equate it with the value of M. We would say angle M if we didn't know what angle M is, but we have been told that angle M is equal to 110 degrees, and we got that from the statement. So we say 2p plus 30 degrees equal to 110 degrees, and remember we need to write our reason. So our reason is core angles. We can say chorus angles, or we can say core angles. That's fine. Short, and then we state the lines that are parallel. Very important. Why are we saying these angles are equal? It's because AB is parallel to CD. So we do that in following our chorus angles. And there we have it. That is our reason. It's a full reason because we didn't say corresponding angles alone. We also state the parallel lines. And I need to emphasize that, guys, you need to make sure you state your parallel lines, because if you fail to do that, then basically you will lose out on the marks that you're supposed to get if you do not state the parallel lines. Then you solve. 2p is equal to, we transpose the numerical values, and when we do that, remember, we change the sign, because when we transpose a value from one side to the other, it changes signs from positive to negative. It was negative, it changes to positive. Then we go ahead and solve. 110 minus 30 degrees gives us a whooping what? 80 degrees. Then obviously we divide both sides by the coefficient of P, which is 2. So when we divide both sides by 2, what happens? P is equal to, obviously you divide this by 2, you divide that by 2. Want to get rid of this 2, you're left with P alone, and 80 divided by 2 degrees is equal to 40 degrees. And there we have it. That is the value of P. Done and dusted. I mean, really and truly, such a nice flow. And it's so nice, guys, when you know these relationships that exist between parallel lines, then it makes life so easy. But if you don't know the relationships, your fun relationship, fun X, if you will, your corresponding angles, alternate angles, the fact that they are equal, your co-interior angles, the fact that they are supplementary. Remember, the word supplementary simply means that those angles add up to 180 degrees. Those are your corresponding angles. And then your angles around a point, guys, your angles around a point, the fact that those angles, they add up to 360 degrees. And then X, of course, those angles are vertically opposite angles. Let's move on to 1.3.1. Determine the value of A and B in alphabetical order. All reasons must be given. The value of A and B in what? In alphabetical order. All reasons must be given. So this is the A, small letter A. This is the B, small letter B. So far in this diagram, we have A, small letter A, and B. Okay. So now we are supposed to calculate, giving all reasons, all right? We need to find A and B. So first and foremost, when we look at this diagram, you can see that ST is parallel to RQ. So between these parallel lines, we should see relationships that have to do with parallel lines. Also, we have A here. We have 80 degrees. This is our X. So basically, we can find our A value. I'm sure you guys can see what the A value would be and what the reason would be for that. Then we have B here. B has a relationship with this 110 and 20 degrees. I'm sure you guys can see that because SV is a straight line. And 120 is from this part of the straight line all the way to here. And then from here to B, we complete a full what? Straight line. So when we complete a full straight line, it means that the sum of these angles should give us a 180 degrees. So let's go. Let's first start with A, because they said determine the value of A and B in alphabetical order. So we don't want to break what they have asked us in the instruction. And it's very important, guys, that when you about to answer a question, please make sure that you've read and understood what they expect from you, because what we don't want to do is we don't want to find the value of B before we find the value of A. So let's go. A is equal to 80 degrees. What is the reason? Vert op angles. Clean. All right. Then B and 120 have a relationship. They have a angles on a straight line relationship. So B plus 120 degrees is equal to what? 180 degrees. Our statement first, then followed by our reason. Angles on a straight line. Angles on a straight line. Okay. Then we solve for B. B is equal to 180 degrees minus 120. Remember, when we transpose a value over to the other side, especially if it's a separate term, it changes sign. Then B is equal to what's 180 minus 120? It's a beautiful 60 degrees. And that's in the bag. Okay. Guys, how sweet, how nice, how beautiful. So B is 60 degrees. Okay. All right, let's go. Let's move on to the next one. Determine the value of the variable in the diagrams. Give reasons for your answer. So of course we're going to give reason for our answer. So look at this diagram. It's so nice, so straightforward. F-U-N. F. Okay. Now obviously this is shaped as an F, but look at the position of the angles that are given to you. Even though this is an F and obviously AB is parallel to CD, remember that A and 105 degrees, which shape do they actually remind you of? Which shape do they remind you of? Is it the F shape? If you're looking at the two angles, it's U, right? It's the C, it's the U. And the U, it's like you taking your two arms, you extend them in front of you, and you see that, oh, it's the angles at the armpits. And what do we know about the angles in the armpits? When we add them together, we should get 180 degrees. Yeah. It's like Makwapa vibes, right? A plus 105. So we need to write a statement. A plus 105 degrees is equal to 180 degrees. And this is the way to go, guys. All right? And we write our reason. What's the reason? Co-int angles. And remember, we need to state the parallel lines. Let's not forget to state the parallel lines. AB is parallel to CD. This is it, guys. All right? Then we solve for the unknown. Don't forget to solve for the unknown. A is equal to 180 degrees, minus 105 degrees. Okay? And then 180 minus 105 gives us a whooping 75 degrees. And that's it, guys. I mean, in the bag. In the bag. In the bag. So 180 minus 105 gives us a whooping 75 degrees. And that's because, and you see, it could be very easy for someone to fall into the trap of thinking that, oh, the relation, they see the F, right? They look at the F sign and then they think corresponding, the two angles must be equal. Please, guys, just always take note of what relationship exists between the two given angles. And the relationship that exists is the C or the U relationship, because these two angles are the two angles that are interior to the two parallel lines. And when these angles are interior to the two parallel lines, we call them co-interior. The word co is like together, and interior means inside. So we are together inside. We are the armpits together within our arms. Are we together? Yeah. Okay, so let's go. Next. 1.3.3. Determine the value of the variable in the diagrams. Give reasons for your statements. Determine the value of the variable. So once again, the first thing we do before we even jump into this, we check what is the relationship between what we have been given and what we are trying to find. So what we've been given is 106 degrees. What are we trying to find? X. Is there a relationship that exists between these two angles? Almost definitely. What relationship exists between them? It's that Z, that funny one, that funny Z, okay? I'm sure you guys can see it. So this is a typical alternate angles. But are they equal? Yes, indeed, because when EF is parallel to GH, we can say those angles are actually equal. So what's our statement? X is equal to 106 degrees. What is the reason? Let's not forget, we do write alt angles for short, but then we must state the lines that are parallel. So what lines are parallel there that make it that the angles be equal? EF is parallel to GH. Okay, we feeling this? So that's it, guys. That's it. Done and dusted. Marks in the bag. All right. Okay, let's move. Okay, please, let's not forget to do this. We need to state the lines that are parallel when we write alt angles. So these are the three things that we need to make sure we always write the parallel lines for whenever we state the reason. Whenever you use the F relationship corresponding on top, bottom, that corresponding angles that you use, you need to state the lines that are parallel. Because there's a condition, guys, for the angles to be equal. For corresponding angles, the lines need to be parallel. So you need to state the lines that are parallel as part of your reason. For alternate angles, you also need to state the lines that are parallel for your reason to be complete. And then last but not least, for co-interior angles, your armpit angles, your armpits, your smelly, stinking armpit angles, the addition of those two angles gives you 180 degrees, okay? And basically that, yeah, that's an important relationship. Let's move on. Next. 1.3.4. Determine the value of the variable in the diagrams. Give reasons for your statements. Guys, if you feel like these questions are very easy and so forth, they are supposed to be, right? Because the whole purpose of us actually doing these questions is so that we can get into the game when it comes to the concept that we should have when it comes to the geometry questions. So determine the value of the variable in the diagrams. Give reasons for your statements. Now you can see clearly that this is a triangle, but it is extended, or it is produced to produce something that we have this angle, and this angle we refer to it as the exterior angle. Now people, I just do want to say that an angle that is exterior needs to always be in line with the side of the triangle. If it is not in line with the side of the triangle, then it is not called an exterior angle. At least not the exterior angle that we know is equal to the sum of the two interior opposite angles. And by that I mean this angle is an exterior angle, and it's equal to the sum of the two interior opposite angles. This angle is the exterior angle, and it is equal to the sum of the two interior opposite angles. This angle is called the exterior angle, and it is equal to the sum of the two interior opposite angles. But take note, people, this here, if let's say this here is not the exterior angle that is equal to the sum of the two interior opposite angles. Why? Because it is not in line with the side of a triangle. So it is disqualified from being the exterior angle that is equal to the sum of the two interior opposite angles. These two are equal to the exterior angle. This is the real exterior angle. It's actually in line with the side of the triangle, as well as this. This is the exterior angle. It's actually in line with the side of the triangle, and that is also the exterior angle because it is in line with the side of the triangle. Now, I'm sure you can see that this is a type of triangle. This is a special type of triangle. What type of triangle is this? Based on the symbols that we see on the triangle. What type of triangle is this, guys? Yes, Naledi, it's an isosceles, and Biggie, you got it. Aluta, me, no, Kamukholo, yes, Kamukholo, the Shoni boy tides, yes, it's an isosceles. Now, very easily put then, right, we would know that this angle here, this angle down there, is actually equal to 43 degrees, all right? What I don't like about this diagram is the fact that they did not allocate letters so that we can basically move in the direction of finding other things. It's very important that they do that. I mean, this examiner, whoever they were, they should have actually made it a point that they provide such for the kids so that they can be able to move. Okay, it's really unfair when they don't do that. It makes it so that learners cannot do what they need to do in the way that they ought to do it. Because the learner would first have to say that this here, all right, this angle B is actually equal to what? 43 degrees. And there's a reason why. The reason is angles opposite equal sides. I mean, that's where we would start. Okay, we'd start filling in the information that we ought to get based on what we see in the diagram. And this is not assumed, okay, that this angle is equal to 43 degrees. It is the fact that we need to state that it is equal to 43 degrees. And there's a reason, guys. The reason is because these two are angles that are opposite sides that are equal, which is very important. So we need to explicitly state that that angle is equal to 43 degrees. So I must be honest, I personally don't like the fact that the examiner did not put the letters here. He should have gone to that length so that, or at least assign a variable in this place so that you can find that angle, and then after that you can go ahead and find this exterior angle. Okay, now once you have that angle, it's very easy now to then go ahead and tell us what the value of A is. Simply put, A, which is the small letter, is equal to 43 degrees, this 43 degrees, plus this 43 degrees, plus that 43 degrees. That's our statement. And the reason is exterior angle of triangle. That's simply put. Exterior, we put X for short, angle, the symbol angle of what? Of triangle. And then A is equal to, we just add those two angles. The two angles give us a whopping 86 degrees. So yes, A is 86 degrees. And what I really like personally is that every single time I find something, okay, what I usually do is I fill it into my diagram. For instance, when I found angle B, I put it in my diagram. I update my diagram so that by updating my diagram, I can see what the new information that I now have, what the new information that I've got, as how that assists me to be able to prove or find what I'm still missing in the diagram. Okay, thank you so much, Matimba. Thank you so much for the rose. So yes, this is what's beautiful about being able to update your diagram, you know. Thank you, Jason. Really appreciate it. So yes, guys, thank you for the rose. Exterior angle of triangle. I hope that is very clear for all of us. Thank you, Kamukhelo. Kamukhelo, you're back. Even though it's not a grade 11 session, I still remember you from that other night. Yeah. Exterior angle of triangle. A is equal to 86 degrees. Hello, Tracy Selo. It's nice to have you. Nice for you to poppity pop in here. Okay, question 2. Determine the value of X. All reasons must be given. Okay, so first and foremost, before you jump into the question, let's just analyze what's in the diagram. So we have a parallel line, two parallel lines. We have a parallel line there. So those two lines are parallel, which is sweet. We have Y. Between these parallel lines, we have two triangles, which is also beautiful for us to note. Okay, then we have Y there in one of the triangles. Okay, then we have X in the other triangle. Then we have 90 degrees, which is that box, and then we have 38 degrees there, which is something that we do know. Now, what we want to find is the value, as it says, determine the value of X. All reasons must be given. Did they ask us to find the value of Y? No. People, so let's just answer the question and not try and answer all other questions that have not been asked. So this is very important. Look at the diagram check what is being asked and then answer the question. Don't answer questions that you're not being asked. So X is in the triangle. What do you notice about the triangle? It's a right angle triangle. What do you have in it? You have 90 degrees, you have 38. X is unknown. Can you find X the unknown? Oh, most definitely. Most definitely. It's the unknown, and it's the only unknown in the triangle. Okay, it's fine, Enrique. Okay, let's go. So in triangle, in that triangle, we're going to say X plus the 38 degrees plus the box says 90 degrees. Let's not forget that this box means 90 degrees is equal to what? 180 degrees. And then our reason, now I know some people will say sum of angles in a triangle. That's fine. I know that with my learners, I tend to insist, and I've actually told my learner interior angles of triangle. I've told my learners to just choose one reason and stick with it all the way from grade 8 up until grade 12, so that, you know, they are consistent. You know, once you establish a sense of consistency in answering a certain question, and especially with geometry, reasons don't change, right? And the reason that I'm using here is actually a reason that is in a document that educators use when they teach. It's a document that's even used when educators mark in the marking centers in grade 12. So interior angles of triangle. Or you can say sum of angles in a triangle. Or your angle sum in a triangle. I mean, guys, I think there is a bit of liberty, but you know, I tend to be a bit more strict with my learners so that they can get these things up and rolling even now. Okay, so then it's transpose. We transpose the values. Remember, the 90 degrees goes over to the other side, becomes minus 90. 38 goes over to the other side, becomes minus 38. Then we solve for X, and I'm just going to wait for someone to beautifully help me and assist me with that beautiful answer. 180 minus 128 gives us a whooping 52 degrees. Thank you, Naledi. Thank you, your girl Angie, BNG, Braku, me, Tsepang. I can see some people are like, we are on the money here. Like, we are on the money, which is so good. Okay. 2.2. The quadrilateral below is a square. Okay. Here we go. The quadrilateral below is a square. Determine the value of X and Y in alphabetical order. All reasons must be given. So what are we told? The quadrilateral below is a square. Now the first thing you need to make sure you do, okay, what are you saying? You are not done. I am very much done. The question says, and I answered the question, determine the value of X. All reasons must be given. And this is the beauty or the art of answering and making sure you understand the question that they asked you. Okay, if you are someone else, you're gonna chill there and find why, of course, and all of that stuff. But did they ask us for why? No, they didn't. This is just a detractor. It's just there to distract you, and someone else will go ahead and find that why. And I mean, if we look at the question specifically, that's a waste of time, because we want to answer the question and move on so that we can get to the more serious, maybe more heart-burning questions that we may have. Okay, but that's fine, guys. If you are able to see what the value of Y is, well, good for you. Maybe in the question paper that you may have, it may require you to find the value of Y, right? And if you find the value of Y having X, you can definitely get what the value of Y is using the value of X that you now have. What would be the value of Y if they had asked us for the value of Y, guys? Had they asked us for the value of Y, what would we have said? The value of Y. We found that X is 52 degrees. Okay, Lungile, definitely. It would have been 52 degrees. And our reason would have been alt angles. And let's not forget the parallel lines. Since we don't have letters there, we would just write the symbols for parallel lines just to indicate that we do acknowledge that our Y value is that value 52 degrees because the lines are what? Are parallel. It's very important. Okay, let's go. 2.2. The quadrilateral below is a square. Determine the value of X and Y in alphabetical order. All reasons must be given. So now we need to actually tell what this value of X is from the get-go. So if it's a square, hopefully we know the properties of a square. And I've been saying many times on this platform when I've gone live that, guys, please make it a point that you know the properties of a square. You need to know the properties of all the quadrilaterals. You need to know the property of a parallelogram, all the properties. You need to know how to sing them. Like, I mean, if I was to come to you at 12 o'clock tonight and just come to your bedside and wake you up and be like, tell me all the properties of a parallelogram, you should be able to comfortably tell me the properties of a quadrilateral without flinching. I mean, of a parallelogram. If I asked you what are the properties of a trapezium, you need to be able to tell me. All right, rhombus, rectangle, and so it goes. Thank you guys for, thank you for these. I really appreciate it. X is equal. So, what's the value of X? The diagonals of a square, they bisect at what? That is the $1 million question. Do we know? Do we know what the value of X is? Okay, very good. X is equal to 90 degrees. Then what's the reason? You simply just say diagonals of a square, and that's it. Okay, diagonals of a square. All right, I know that in the guideline that they have, you can say diags. This is kind of like short form for diagonals. You can say diags of a square, diagonals of a square. All right, I know some people would insist in saying diagonals of a square bisect at 90 degrees. But you know what? If you just say diagonals of a square or diags of a square, that's sufficient. Okay, very good. Okay, diagonals. Remember, diagonals are simply these lines that extend from one opposite end of your vertice to the other. So this is a diagonal number 1, and this one also is a diagonal. This is a diagonal as well. Okay, it extends from one opposite end of your square to the other. That's what we refer to as a diagonal. It's a straight line that extends from one vertex to the other opposite vertex of a quadrilateral. All quadrilaterals, you would say, typically have what we refer to as diagonals. Okay, let's move on. Y. What is the value of y, guys? What do we know about the diagonals of a square? Very good. Y is equal to 45 degrees. Why? Because the diagonals of a square bisect the angle. Bisect the angle, yes. You know that the corner angle of a square is 90 degrees. Each corner angle is 90. So this diagonal, what it does, it actually splits the corner angle into 2 equal halves. So if this is 90, what are we doing to 90? We are dividing by 2. What do we get? 45 degrees. So our reason here would be, you would be so right if you say diagonals of a square. That's the funny thing. If you write diagonals of a square, the person who's marking will understand what you mean. If you say y is equal to 45 degrees, they will know very well. If you say diagonals of a square, they know very well, oh, this person understands that this diagonal, what it did, it bisected the corner angle, which is 90 degrees. So by saying y is equal to 45 degrees and simply saying diagonals of a square, you are spot on. You have done a phenomenal job. Okay, let's move on. Next. Let me just wipe my lens there for a moment. I think it's a bit fuzzy. Okay, there we go. 3.1. Give one minimum condition for congruent triangles. Give one minimum condition for congruent triangles. What are congruent triangles? Guys, the word congruency simply means when two-dimensional, if you're talking about congruent triangles, if there's 2 triangles and you say they are congruent, you basically mean that they are the same. How? They are the same in every way possible. Their angles are the same and their sides are the same. All right. So if you're going to ask me to give one minimum condition for congruent triangles, I could basically say when all three sides are the same. Okay, when all three sides are the same, or in other words, when all three sides are equal. That's one minimum condition. Remember, okay, for congruency to be true, the sides of two given shapes need to be equal, as well as the angles need to be equal. All right, so one minimum condition one can give is simply say side, side, side. What does that mean? It just means for these two triangles that you may have that are congruent, it means that the corresponding sides are actually equal. So if you said side, 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 that's perfect. Okay. Someone else maybe could have said side, angle, side, SAS. Or someone else could have said RHS, which is right angled hypotenuse side. Or someone else could have said something else. Is this a real paper? It is a real paper. I'm just not so sure it will be the paper that you'll be writing, because no one knows the paper you'll be writing, right? Yes, you can say SAA, definitely. That's another minimum condition, right? SAA, all right? So there are 4 cases of congruency. You could choose one. Side, 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 that's one. Or you could say side, angle, angle, all right? Or you could say RHS, which is right angled hypotenuse side, all right? Or you could say side angle side, which is basically another condition. Okay, let's move on. Grade 9 people, 3.2. But all the people who are here and they're like, hi, but this is similar to grade 8. Well, catch a wake up, guys. That's exactly the point. You guys who are going to be crossing over to grade 9 next year, you better not throw away your grade 8 maths. You better not in any way think, but I am done with grade 8 maths. Here we come, grade 9, and therefore like that's it. No, guys, you have to be in par with your grade 8 maths. That's how easy your grade 9 will be when that comes along. Now the following question that I'm about to do is not a grade 8 question. Okay, line segment QR is parallel to line segment ST. Let's look at this. Line segment QR, this is line segment QR, is parallel to line segment ST. Where's ST? ST. So those two lines are parallel. Complete the following proof that triangle QRU. Now, what is this? What do these symbols mean? What do these symbols mean? No, they don't mean congruent. They don't mean parallel. Faith, you are spot on. Faith, together with Slibo, Pink, Jake, Chi, Vigil, Naledi, Brooke, you guys are spot on. These lines mean similar. 3 vertical lines, guys, mean similar. So in other words, triangle QRU is similar to triangle TSU. Complete the following proof that triangle QRU is similar to triangle TSU. Now, guys, for similarity to hold, there are 2 fundamental cases, and I'm just going to quickly look at this. Case number 1 has to do with proving that 3 respective corresponding angles for the respective 2 triangles are equal. There's angle, angle, angle. So there's case angle, 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 which applies to similar triangles. Or you can prove that the sides are in the same proportion. 1, 2, 3, right? Sides in proportion. Okay, those are the 2 cases of similarity. There's angle, 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 or you can prove that sides are in proportion. So this is very important to note the 2 conditions that basically apply to similarity. Okay, so let's quickly look at this. Look at this very quickly. So here we are in triangle QRU and triangle TSU. Statement number 1 says RQT. Remember, the middle letter represents the angle. RQT. RQT, meaning this angle here. They are saying RQT is equal to QTS. This angle, they are saying, is equal to this angle. And then they are saying the reason that is the case is alt angle. Why? Because QR is parallel to ST. Okay? So I repeat this, guys. In triangle QRU and triangle TSU, they are saying RQT, meaning this angle, middle letter representing the angle, is equal to QTS, meaning this angle. And the reason they are saying that is alt angles. QR is parallel to ST. This is a very true statement, and it's a very true reason. So in other words, we can then say that this angle is equal to this angle. Okay? And this is our first A angles, respectively, for the two triangles that are equal. Let's move on. Now they are saying angle QRS. Let's go. Where's QRS? QRS, meaning this angle. So what I'm going to do is I'm going to just put a double just to show this angle is different from this one. Is equal. The question is, what is angle QRS equal to? Angle QRS is equal to which angle in this triangle? Angle QRS, meaning this angle, is equal to which angle? It's equal to angle S, right? So we are just going to use the same notation. TSR, or we can say RST, middle letter. Okay, so let's do this. RS with a cap to signify the angle we are referring to. RST. Okay, this angle. So these two angles are actually also what? Equal. What's the reason for them being equal? Do we know the reason? Because I need to write the reason. I need to fill it in here. Do we know? The reason. Very good, Tapelo. Thank you so much. Tapelo is on fire. Alt. Yes, you guys are all on fire. Thank you so much. Those who have responded. Alt angles. Then let's not forget to state the lines that are parallel after that. QR is parallel to ST. Guys, almost like clockwork, you need to make sure you state the lines that are parallel. Do not make the mistake of just saying alt angles and not stating the lines that are parallel. This is our second A. Seems like our case is coming on nicely, if you ask me. Seems like our case for similarity is coming on very nicely. Okay, let's move on to the last statement that has been stated here. It seems like the reason is vert-op angles. Okay, but which two angles here? TUS. What is TUS equal to? The middle. 1, 2, 3. TUS is equal to? Yes, Nuri. Yes, Nuri. So it's TUS, this angle, is equal to RUQ. So I'm going to say in the same view, RU with a cap with the middle in the middle letter, RUQ. Or we could say QUR. Okay, as long as the middle letter, we always know it signifies the angle we are referring to. And people, the reason why RUQ is equal to SUT could only be one reason. It's not common angle. It is these two angles, the X relationship. Remember the X relationship, fun X. This represents vertically opposite angles. Okay, very, very important. So that's why already they filled in the reason for us. It's just a matter of identifying the two angles that are equal. So SUT is equal to RUQ. We filled in the angle that is supposed to be equal to TUS. Smack bang, guys, vertically opposite angle. Look, this is our third A. 1, 2, 3. A. In other words, angle, angle, angle. Case of similarity reached. We have proven. Now, triangle QRU. Look at the order, guys. Triangle QRU. Look at the Q where it's situated. Look at the Q where it's situated. Which angle, all right, did we say this angle is equal to? It's equal to this angle. Look at where the T is situated. So this angle, first place, we know those two angles are equal. This angle R, this QRU, we said it's equal to what? That QRU was equal to, obviously it was equal to RST. Look at this, look at this. This angle is also equal to that one. And then last but not least, this U for this triangle is equal to this U for this triangle. So the order in which you place your letters basically confirms that angles are equal. Each respective angle for the respective triangles is equal. So the case of congruency has been proved. So if we go back to the question, what did they say? Line segment QR is parallel to line segment ST. Complete the following proof that triangle QRU is similar to triangle TSU. Didn't we just do that? Yes. How? By using one of the cases of similarity, which is A. Guys, the case of similarity, A, is only a case that is applicable to similarity. A, it does not apply to congruency. Okay, we talked about the cases of congruency. A only applies with or applies to similarity. This is one of the cases of similarity. What I also mentioned earlier on as well is that there's a second case of similarity, and that has to do with sides being in proportion. All right. So for this particular question, they wanted us to prove similarity, but it was using what? Using the first case, angle. So there it is, guys. Case closed. A. All we did was just fill in what was missing. So that's what's nice about this particular question, is that they required us to just fill in what is missing. Okay. Someone is requesting me to be live at 8 o'clock. Guys, I cannot promise 8 o'clock. Why? Because this is just me. At the moment, I hopped onto this thing because I just thought grade 9s are writing tomorrow. So I just need to kind of utilize the time. You know, I'm a family man. So I do obviously need to take care of other important pressing matters in the home. You know, so 8 o'clock, I may or may not be able to go live. So I cannot really promise anything. Okay. Why specifically? Let me see, Miss. It seems like you've been insisting. Sorry, it's just that Mrs. M has been saying go live at 8 o'clock. I wonder why 8 o'clock specifically. Why 8 o'clock specifically? Okay, prove that triangle ABD. Now look at the symbol, guys. This time round, prove that triangle ABD. Look at the symbol. What symbol is this? Are we still talking about similarity? This is not equal. Guys, this is not equal. Yes. 3 horizontal lines. 3 horizontal lines means congruent. Congruent. Okay. Oh, that's when most learners are studying and are focused. Okay. At 8 o'clock. I'll see, guys. Like I said, I'll see. I'll bank on it and prepare for it, but like if it does not happen, you must understand it's because, like I said, there's kind of a bit I have commitments then. And what I will do is I'll actually take I'll download this video and post it onto my YouTube channel, so you guys can go and subscribe there, and I'll actually upload this video so that those who came in a bit late can actually rewatch this at their own pace, you know, sort of like in their own time. Prove that triangle ABD is congruent to triangle CED. So we are not looking at similarity now, we are looking at congruency. How many cases of congruency? We have SSS, we could use that. We have SAS, we could use that. We have angle side, which sometimes can also be SAA. Or last but not least, we have right angled hypotenuse side. So there are three cases that this could potentially fall into. All right, so let's go here. Let's look at the shape. You can see, Moss, it's pretty much the same diagram that we had from the previous similarity case. But let's quickly look at this. This side we are given AD is equal to DC. Can you see that? Okay, so let's do this. Maths is a Game is the name of the YouTube channel. Maths is a Game. It has, I think we just recently hit a bit of like it was like 200 or so odd subscribers. You should be able to see like some of the past live videos that I've done for grade 8 paper 1 paper 2, grade 9 paper 1 paper 2. You can check those out as well. Maths is a Game. It's kind of like the same channel name that I have for the TikTok page. So Maths is a Game. Everything is Maths is a Game. There's also a WhatsApp channel as well, where I've uploaded some of the papers that have been written, some of the past papers. They are in picture format. I'm just thinking for those who just want to go on WhatsApp, and so the link is on my bio. You can check it out, the WhatsApp channel. So it's the YouTube channel. You can go and actually click on the icon, the YouTube icon. It will send you directly there. Subscribe. Future videos that I'll be posting, things that I've done here, I'll post them directly there. Also, like I think whilst we're still on the topic, I am going to do some summer sessions during the holiday period. I know most of you are not going to be thinking of mathematics at all. I'm doing this for the benefit because some people have requested. They want to start a bit early in preparation for grade 8, 9, 10, 11, all the way to 12. So I'll actually be posting up a schedule here of like some sections of mathematics for all these grades, grade 8, 9, 10, 11, 12. So it would be beneficial for a grade 7 who's coming on to grade 8, who's like, I want to start early, I want to get familiar with what's happening in grade 8. I'm from grade 7. I want to start early. I'm in grade 8. I'm going to grade 9. I want to start early. I have chosen pure maths in grade 10 next year. So I want to start early in grade 9. It will be beneficial for those people. It will be beneficial for those who are going to grade 11 because I'll be starting a bit early with certain sections that you'll be covering in your grade 11 syllabus. And those who are actually going from grade 11 to grade 12, I'll also be doing stuff on that. So I'll post the schedule of it in the holiday season, the time, the dates, and all of those things, so people will know when I'm going live, what I'm doing, and what it is I'll be focusing on. If it fails here on TikTok, I'll be doing lives on the same time frames on my YouTube channel, because at the end of the day, all I want to do is just help the nation do well in maths. And in actual fact, guys, a level 5 to a 7 in mathematics is so possible. 100% in mathematics is so possible. I've been seeing that with my students big time, because like at the end of the day, if you do what you're supposed to be doing, there's nothing that you cannot do. Okay, let's go back to the maths. So like I said, first statement that we can put there is the fact that AD is equal to DC. I mean, that is given, guys. You can see, Moss, AD is equal to DC. The two lines there tell us that. Okay, AD is equal to DC. What's the reason? It's given. It's given to us. If it's given to you, you just write given, right? These two lines indicate that AD for this triangle is equal to DC for the other triangle, all right? Then next that we need to get. Oh, there we go. Inactivity. All right, let's go. Sorry, I had a bit of a inactivity detection from TikTok here. Okay, angle A, we can say for the one triangle is equal to angle C in the other triangle. I'm sure you guys can see that. Angle A is equal to angle C. Remember, these lines are parallel. If the lines are parallel, what do we know about these two angles? The two angles are alternate angles. So I will say BAD is equal to DCE. Angle BAD is equal to ADCE. Or you can say ECD, as long as the middle letter is the letter that you are, whose angle you are referring to. Okay, right. So those two angles, BAD is equal to ACE or DCE. All right. Or you could just say, guys, angle A is equal to angle C. Why can you say that? You could say angle A is equal to angle C. It's because already in your triangle, what you've done, I mean, when you started out in your statement, you said in triangle ABD and triangle CED. So if you simply say angle A is equal to angle C, I will know because you've identified the two triangles you are working with. Okay. Yeah, that's fine. Okay. Yeah. So angle A is equal to angle C. Okay. Yeah, go get this. Even if you say angle is equal to angle E is equal to angle C. Alright, guys, you can't say angle E is equal to angle C. Go get, we can't say that. Okay. Because I would ask, what's your reason for saying angle E? Because you're saying angle E is equal to angle C. What's your reason for saying that? And remember, when we do this, we are doing it to prove the congruency of the two triangles. Oh, okay. Okay, you meant to say A. That's fine. If you say angle A is equal to angle C, that's perfect. Why? Because you laid it out in the beginning that you are looking at triangle ABD and triangle CED. So, but when you say angle A and angle C, I know which triangles you are referring to because you stated it before that, okay? So angle BAD, just allow me to just continue with what I said. Angle BAD is equal to angle DCE. What's the reason? Alt angles. And then we state the parallel lines. Don't forget that. AB is parallel to what? To EC. Very important. If you don't state the parallel lines, guys, you're just going to chuck away marks for no reason. Please make sure you state the parallel line. Don't just write alternate angles. It's not good enough to just write alternate angles. Then the next thing, angle B, obviously, is also equal to angle E. I'm sure you guys can see that. Angle B is equal to angle E. Or in other words, angle ABE is equal to angle BEC. So I'm just going to say ABE cap in the middle is equal to CEB cap in the middle. Okay? And then lastly, you just say alt angles. And then the lines that are parallel, AB is parallel to EC. There we have it. Now what do you see here? We have side, angle, angle. Do you see that? Side, angle, angle. Okay? Side, angle, angle. That's one case you could potentially utilize to prove the congruency of these triangles. Then you conclude triangle ABD. Remember, they said prove that ABD is congruent to CED. Triangle ABD is congruent to triangle CED. Then you write your case in brackets SAA. SAA. Okay, this is grade 9. So yes, people, this is how we were able to prove the congruency of triangle ABD and triangle CED using side, angle, angle. Now someone else might be like, but sir, there's something else that I can see from the triangle. There's something else that I see personally in proving the congruence of this triangle. Then if you see that particular thing and you can actually follow it up appropriately and accurately, and it is in support of one of these cases, then that's fine. You can go ahead and do that, right? Yeah, because sometimes, or let me say most of the time in geometry, there's not one single way of doing a particular question. There's many ways that lead to the very same answer. So if you want to prove this congruency of these two triangles and you utilize accurate methods, all right, that lead to accurate answers, then that's spot on. That's also fine. Okay, that's absolutely acceptable and we good to go. I'm thinking someone else, maybe we could have started it off like this and said AD is equal to DC. Very true. It's given, right? Then after saying that, they would have said, okay, let me just write this down. Someone else would have said AD is equal to DC. Reason, given. Okay, and that's true, right? Because AD is equal to DC. Why? Because there's these two lines that indicate the two sides are actually equal. 2. Someone else could have said angle ADB is equal to angle EDC. Angle ADB is equal to angle EDC. In other words, this angle is equal to this angle. Someone else could have said that. Okay. Now, do you see what I have so far? I have this side for the respective triangles, and I have this angle for the respective triangles. Then, at the end, someone else could have said, and in actual fact, this angle is equal to this angle. In other words, angle A, yes, let's not forget the reason. The reason why we said this angle is equal to this angle. Thank you so much, Lwandile. You are the man. The reason why we said this angle is equal to this angle is because of vert-op angles. Okay. So statement number 1 has to do with S. Statement number 2 has to do with A, because we've identified two angles that are equal. Statement number 3 can be simply taken from any of what we have seen. We also saw in the diagram that angle B is equal to angle E. Or we could say angle A is equal to angle C. So if we go ahead and say angle A is equal to angle C for those two triangles, what's the reason? Alt angles. AB is parallel to CD. All right. That is our third what? A. S-A-A. So here's another situation where we've identified a slightly different statement, one of which said we have identified vertically opposite angles, and then we were able to ultimately use this case and then say triangle ABD is congruent to triangle CED, and the case SAA. Boom! Another case of congruency proved. Okay, so yeah, this is basically me saying to you many ways to kill a sweet cat. All right, and some of you may feel like, hey, Maths is a cat. Is this for grade 9? Yes, this is for grade 9. Okay. Now, people, let me say very clearly, we can't say D. Can't you say D is equal to D? No, you can't. No, you can't. You can't say angle D is equal to D and say common angles. No, guys, no. Remember, these two angles are vertically opposite angles. This angle D for this triangle is equal to this angle D for the other triangle because it's your X shape, right? We said these indicate vertically opposite angles. They are equal. You can't say it's common angles. Remember, the only time we use common angles is if those two angles were actually sharing the same angle. Okay? Yeah. And there's cases like that most where you have two triangles and you say you use common angle because literally the two angles are shared together. These are not shared angles. This angle D is not a shared angle with this angle D. Okay? I hope it's clear. Okay. All right, let's go. Question 4. Now, transformation geometry, people, is something that you guys obviously should also know very well. Transformation geometry. I just want to say very quickly, then whenever they say left or right, if we are talking about movement, left or right, who is this affecting? Is it affecting the X or the Y coordinate? Who is it affecting? The left and right movement is affecting X or Y. Who is it affecting? It's affecting X. Okay, so hopefully we get that. Left or right movement affects X. Up and down movement affects who? Up and down. Who is it affecting? Who is affected? Yeah. Y is affected, right? Okay. So that is the question. This is the answer. So left and right movement, X is affected. Up and down movement, y is affected. Please, people, I beg you, I beg you, I beg you. What's painful about translation questions? A lot of the times, the kids, they do not know who is affected. I'm going to repeat this. Left or right, the minute we say we moved 3 units to the right, or 3 units to the right, or 3 units to the left, what I'm asking first and foremost, before we jump into actual problems, who is affecting who? Left or right movement, is it affecting x, our x value for our x coordinate, or is it affecting our y coordinate or our y value? All right, so left or right, the minute we say left or right, who is affected? Is it x? And the answer was yes, x is affected whenever we say left or right. Okay, but then the minute we say up and down, who is affected? Y is affected. Okay, now the next question will be how. Okay, so the minute we know who is affected, that's great. The minute we know who is affected, then the next thing is how are they affected. So the minute we say left, we know left means x is affected, but how is x affected? The minute we say x, we say left. How is x affected? Okay. Yeah, we subtract. Very good. Subtract. I love this. How is it affected? We subtract. Okay. Yeah. Because when we say 3 units to the left, 3 units to the left, you must know that to the left means x is affected. But how is x affected if we say to the left? It means we are subtracting some value. We are decreasing. Very good. I love this. But please take note, it's x that is being affected here. All right. The minute we say to the right, how is x affected? It means we are adding. Hey guys, very important this thing. But we are adding to x. Okay. Please, very important. All right. Yeah. Left or right? Who is it affecting? It's affecting x. How is x affected? When we say left, it means we subtract. How is x affected? The minute we say to the right, it means we are adding. Positive. Now let's come there to up and down. We said who is affected when we say up and down? It is y. You guys said it correctly. But the minute we say up, what's happening? Up means we are adding to y. Down means we are subtracting to y. So very important. If we have that sorted, my good people, then I don't know how this thing can be a pain. The next thing I want to talk about, just very quickly as well, as we are still on the subject, as long as we first know what it means, who is it affecting? How is he being affected? Okay. Secondly, there's this thing called reflection. Reflection. Now, the reflections that we have is in the x-axis. We have reflection in the x-axis. Now, they can trick you and say in the line y is equal to 0. All right. Now, this here in, they can say along. They can say on. In, along, on the what? The x-axis. Another similar notation they can say reflection in the line y is equal to 0. Guys, in the x-axis and in the line y is equal to 0 is the same thing. Okay, if you say in the x-axis, it means in the line y is equal to 0. All right. Yeah. He's got. No, don't worry. I'll get to the rotation one. You must first, like I said, get this one, Carl. So we know who, all right, in the x-axis, but how? So the minute we say reflection in the x-axis, it means we change the y value. We change the y value. The y value sign doesn't matter what it was. we change the y value sign. The minute we say reflection in the x-axis, we change the y value sign. Guys, a reflection, it's like, for instance, a reflection of yourself is what you see in the mirror. That's a reflection. You look at the mirror, it's almost as if like someone, the same person that is you is looking back at you, right? Yeah. But the direction in which the mirror image you are looking at, that mirror image is looking back at you. All right, it's not looking, if you are looking in a certain direction in the mirror, it's not like you're gonna see the back of your head in the mirror, right? That's like totally off. I don't, unless, guys, you can tell me that, hey, there's people that look into the mirror, unless it's like vampire stuff. You see, but we're not living in vampire world here. You look into the mirror, you see a reflection or an image of yourself looking back at you. That's basically a reflection, right? That's very important to understand the concept of reflection in that sense. That's like it's a mirror image, okay? So that's very, very important. So like I said, reflection in the line y is equal to 0. It's simply a change of that particular object along the x-axis, all right? Same position, just looking back at you, yeah, along the x-axis. But what does that mean? You change the y value sign. You just simply change the y value sign. So if you're reflecting in the x-axis, you simply look at your coordinates, you change the y value sign. X will stay the same, y will change. That's what reflection in the x-axis means. 2, reflection in the y-axis. What is reflection in y-axis? Reflection in the y-axis, or along the x-axis, or on the x-axis, in other words, the line x is equal to 0. How is it affected? We simply change the x value sign. That's all. Yeah. Then, last but not least, yeah, very good, Naledi, thank you. Reflection in the line y is equal to x. Reflection in the line y is equal to x. So I like what you guys are saying, and I like the emphasis. Like Ukumi, I like what Ukumi is saying. All right, Kumi here is saying that, so reflection in the x-axis, we know who changes, the y value sign change. But then maybe you're going to ask yourself the question, if y changes, what happens to x? X stays the same. Same thing with reflection in the y-axis. Who changes? The x value sign changes. That's what happens. But what happens to y? Y stays the same. Okay, and then last but not least, reflection in the line y is equal to x. This simply means that you swap x for y and vice versa. It's like you're swapping these around. Y becomes x, x becomes y. Y becomes x, x becomes y. This is what we mean by reflection in the line y is equal to x. Okay, so these are the 3 reflections that we talk about, guys. A reflection in the x-axis, we change the y value, x stays the same. Reflection in the y-axis, we change the x value sign. That means y stays the same. Reflection in the line y is equal to x, that means we swap x for y and vice versa. So x and y just swap around. That's all. That's all. Okay, which is very, very key. Okay, I want to first and foremost just cover those bases. I'm going to come up to the other ones. Let's look at this question. Oh, you want to take a screenshot? You screenshot person. You guys and your screenshots. I don't know if it's bro, is it only you and I'm from Sion in this live? What is this? Who is from Sion? Up, sir, up. Okay, so let's do this. Reflection in the x-axis, y is equal to 0. Change the y value sign. I'm sorry about the writing. The writing is not so kosher. I think I should have been a doctor in my other life. Legit 2 minutes. Oh, Moshe, man. Yeah. Okay, we'll do that, guys. We'll do that. Hopefully, you've done all the other papers. There's been like papers that I've been posting up for days. Hopefully, you guys are doing all the other papers. Should have been a doctor in my other life, but just isn't happening. Okay, let's go. Point A15 is plotted on the Cartesian plane. Now, the funny thing is they've misplotted this point big time. It's not even funny. Okay, so let's just be proper. If they say 1,5, it means where x is 1, that's here, all right? And then 5 is here. Y for 5 is here. So where do these two meet? They meet here. So point A15 is supposed to be here. Okay, let's just fix that first and foremost. Okay, you're very welcome, Sleep. I'm very happy they are helpful. So let's just erase this thing. This is nonsensical. So they say point A15 is plotted on the Cartesian plane below. There it is. Okay, let's just assume this A15 is there. X is 1, Y is 5. That's where it's supposed to be. Okay, now 4.1.1 says translate points A 3 units to the right and then 5 units down. Let's repeat. 3 units to the right and then 5 units down. So let's do this. 3 units to the right means we add 3. So let's practically do this on the Cartesian plane. 3 units to the right simply means we count. 1, 2, 3. Where are we? We are at 4. Does it make sense in light of what we had said earlier on? If we're saying 3 units to the right, remember, 3 units to the right affects which coordinate? X, right? How does it affect that coordinate? We add 3, all right? So we add 3 to 1, we get what? 4. Practically, even as we move 1, 2, 3, it makes sense. Where are we situated now? X is equal to 4. Next, 3 units to the right, we're done. Then 5 units down. 5 units down. So 5 units down. So let's move practically. We are here now. 3 units to the right. 5 units down. That means we go down by 5. 1, 2, 3, 4, 5. Where are we? We are here. We are now situated at this place. All right. Where? Here. Okay. We moved 5 units down. So let's be practical. A1 plus 3. 3 units to the right. What does the image give us? We get 4. And then y 5 units down. We had 5. Now it says 5 units down. It means we subtract 5. What do we then get? 4 and 0 is the image we get when we add 3, because we moved 3 units to the right, and we know to the right affects x. So we are affecting x. How? To the right means we add 3. Then 5. We are told that, and then 5 units down. What did we have? We had 5. But when we say 5 units down, what are we affecting? Y. Y is 5. But if we say 5 units down, it means we say minus 5. So 5 minus 5 is 0. What is our new set of coordinates? The image, it's 4 and 0. All right. So translate 3 units to the right and then 5 units down. This is basically where we would have our image. We need to show that on the diagram. This is where the point would be, all right? And I mean, you saw what I did. I moved 3 units to the right as they asked. 1, 2, 3. And then I moved 5 units down. 1, 2, 3, 4, 5. So we are here. There, guys, my image of A, my new image, right? Then they say now write down the new coordinates of point A. There we have them. Remember what I did? What does 3 units to the right mean? It means we add 3 to the existing x value, which was 1. Then 5 units down means we subtract 5 from the existing y value. So what did I get as my new coordinates? 4 and 0, the image. So it's A, 4 and 0. Phakathi inside, No problems, because we understood exactly what this meant, because we have an understanding already. Okay, let's move. Next. Here we are. Gems, yes, I am. I am a maths teacher and I am a tutor. I am everything that is mathsified. I am everything that you need as far as maths is concerned if you want to do extremely well in maths. Guys, I don't teach for people to just pass or just make it by the skin of their teeth. I teach so that people can get level 5, 6, and 7. In actual fact, get a level 7 that is just mathsified. Yes, mathsified. Everybody that gets taught must be mathsified. Must love maths. It must be in your, must burn in your bones and blood and everything that has to burn. Okay, all right. So, sure, screenshot please, not Prince insisting for screenshot. Remember that this was this was actually the point where A1 and 5 is supposed to be. It's here. All right, so even if I post the paper, guys, just remember this is the point, because what they drew for me is absolutely out. It's incorrect. I mean, you can't have A1, 5 being here. Makes no sense at all. All right, yes, the 5 makes sense, but the X coordinate being 1 here, rubbish. So need to be very careful of that. I'm sorry about the lingo. Okay, then let's go. We need to go. Look at this. Draw a triangle ABC with vertex coordinates of A minus 3 and 5, B minus 6 and 3, C minus 2 and 3. Draw. So let's draw A minus 3 and 5. Where's X? That's negative 3. It's here. Where is 5? That is Y. We are here. Where do daddy and mommy meet? They meet here. So there they are. Marriage day, wedding day. B minus 6 and 3. X minus 6, that's here. Y, that's positive 3. That is here. So where do they meet? There. That is the point B. So we have B, we have A here, and then C. C is minus 2 and 3. Where's X that is minus 2? X that is minus 2 is here. Where is Y that is positive 3? Y that is positive 3 is here. So where do we meet? Because we X minus 2. No, that's not X minus 2. X minus 2 is here. What are you doing? You, sir, you are misleading the masses. X is minus 2 is here. Y is positive 3 is here. Where do we meet? We meet exactly here. It's very important. Okay. That is C. Now look at this triangle. There it is. Connect this. This needs a ruler. You do it with a nice ruler because these are in the same horizontal plane. And then you connect these two. There's your triangle, guys. Okay. Let's repeat. Minus 3 and 5. X, that is minus 3, is here. Just before negative 2, negative 3. And then Y, that is positive 5, is between 4 and 6. It's there. Where do they meet? There. So that's basically A. B, minus 6 and 3. X, that is minus 6, is here. Y, that is positive 3, is there, guys. Where do these two meet? They meet exactly there. All right. And then last but not least, C. X, that is negative 2, is here. Y, that is positive 3, is there. Where do they meet? X, that is negative 2. Y, that is positive 3. They meet exactly. You say you go vertically. Then you go horizontally. They meet there. Right? So now you have A, B, and C. And you just simply connect the dots. It's like playing dot to dot. I don't know if you guys in primary school you did dot to dot. You could say primary school, like dot to dot, when you were in like you played dot to dot, you did those things, and you could say it was preparing you for something. They're trying to acclimatize your mind so that you can get this thing down. Okay, so once again, A, X, negative 3. Where's X? Negative 3. Negative 3 is here. Are you with me? We are here. Then Y, that is positive 5. Y, that is positive 5, is where? It's there. then horizontal, vertical, where we meet there. That's why A is -3 and 5. It's there, here, where Y is 5, where X is -3. Are you with me? Then B, -6 and 3. -6 and 3. X, -6 is here. Y, +3 is there. Where do the two meet? They meet exactly here. Are you with me? And then last but not least, X, -2, that's there. Y, +3, that is there. Where do the two meet? They meet exactly here. And then all you do is you connect the dots. Okay. Yeah, so far, guys, I'm only just pumping out with maths, and the channel itself is called Maths is a Game. This one, the TikTok page, with a YouTube channel that's supporting it, which is also Maths is a Game. You guys are more than welcome to go on there. There's past maths live sessions that I've done for grade 8 and 9. You're more than welcome to go on there and do your thing. 4.2.1, let's check this out. Draw the image of triangle ABC if it is translated using the rule. Draw the image of triangle ABC if it is translated using the rule. X and Y, where X, your X coordinate for A, you add 3, your Y coordinate, you subtract 7. In other words, when we say add 3, it means we are shifting this particular image 3 units to the right. -7, remember X is affected in that way. We add 3, it means we are shifting 3 to the right. -7, meaning we take the entire image and we shift it 7 units down. All right. So that's very important. So let's check this out. Draw the image of triangle ABC. So A, remember, all right, what are we doing? We are adding 3. You add 3 to A, you get X, that is. So I'm just going to simply do this, guys. I'm not going to waste too much time. All I'm going to simply do is I'm going to go ahead and write the new points for A, B, and C. The image after translation. Are you with me? Right, so if I say +3, remember, I'm saying +3 here. +3 means -3 + 3, that's 0. If I say +3 here, what's -6 + 3? -6 + 3 is -3. So I have -3 for B. If I come here, if I say +3 here, I get 1. Okay. Then I go on to my Y coordinates for each one. Now, Y, -7. So I'm going to say -7 to my Y coordinates. If I say -7, 5 minus 7 gives me -2. If I say 3 minus 7, I get -4. If I say 3 minus 7 again, I get -4. Okay. So hopefully we got that. Okay. And then we go ahead, guys, very nicely, and we just sketch the new image onto our provided. All right. Remember, the new image, right? We had A -3 and 5. Please take note. Okay. Remember, we had A -3 and 5. What is this saying to us? It is saying that in the new translated image of triangle ABC, what we need to do to our X value that we had for this triangle, we need to take the X value that you have for this triangle and do what? Add 3. What does it mean to add 3 to what? To X in the triangle that you had given. It means we simply go to -3 for X, we go to -6 for X, we go to -2 for X, and we do what? We add 3. This is the instruction. How we translate is that we add 3 to our X value for each point. So we're going to do that. And this is what happens. You add 3 to -3, you get 0. You add 3 to -6, you add 3 to -6, you get -3. You add 3 to -2, you add 3 to negative 2, you get positive 1. So that is the x coordinates sorted for each point. Now what are we left with? The y coordinates for each point. We need to sort those out. So what do? We move back to what did they say we have to translate. What do we need to do in our translation for y? We need to subtract 7. Okay, so if we subtract 7, then it means we go to each point for y and we subtract 7. So 5 minus 7 will give us 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 negative 2, definitely. Thank you, guys. Then 3 minus 7 will give us negative 4. Thank you, Shamis. I really appreciate that. And then last but not least, 3 minus 7 will also give us negative 4. So I got negative 4 for my B for Y. I got negative 4 for my C for my Y. Now I have my new coordinates. For the new translated image of triangle ABC, when I add 3 to X, as well as do what to Y? Subtract 7. This is what this means. What did you do to X? We added 3 to X. How does it affect it? I add 3 to my X for each coordinate pair. How was Y affected? We subtracted 7 from Y. How does that affect the new image? You subtract 7 for each Y coordinate. And then go ahead. You simply write down the new Y values. Then you plot them. Then you plot them. So 0 and negative 2. Where is 0 and negative? So X, 0 and negative 2. We are here, guys. That's 0 and negative 2. Is it? Nah, not even, man. I wanted to check if people are actually awake, but I see you guys are not awake. Okay. So 0 and negative 2. X for 0. Remember, when X is equal to 0 everywhere on the Y-axis. Then you want where Y is negative 2. So where is Y negative 2? We are here, guys. That's where we are. 0 and negative 2 is smack bang here. So that's where A is. Let's move. Next one. Where B is negative 3. Where is B negative 3? It's here. But where is Y at the same time negative 4? We are here. So B negative 3, we are here. Y negative 4, where do we meet? We meet here. That's where we are meeting. And then last but not least, where X is 1. X is 1. Y is negative 4. Y is negative 4. We are here. Okay. And then look at this. Look at these two images. Look at that and look at that. So this is a typical situation of two triangles where we have applied a particular translation utilizing what? The shifting of that particular triangle by 3 units to the right, because we understand what plus 3 means, and by shifting the same triangle 7 units down. That is our translation. Yeah. Must the triangle be on scale? In other words, the given diagram sheet will be on scale. So the triangle will be on that scale that you've been given in the sheet. As long as the coordinates, they just are correct. All you need to make sure is make sure that the coordinates that you have for the newly constructed triangle are spot on. No errors whatsoever. Spot on, spot on, spot on. Now look at this one. Now look at this one. Reflects triangle ABC about the y-axis. I think they wanted to say reflect. So that's a typo. reflect triangle ABC about the y-axis. In other words, what do we understand by reflecting about the y-axis? And remember, they are saying here, reflect triangle ABC about the y-axis. Okay, so we are going back to the original triangle ABC. Okay, guys, I cannot re-explain this again because, like I said, those who have been on the live, they've actually been catching on in what I've been doing, and that's from the beginning because I was actually going through this. So what I'm gonna do though is I'm gonna post, as soon as I'm done here, I'm gonna download the video, I'm gonna post it onto my YouTube channel, then you guys can go on there and watch it to your heart's content. And maybe this segment I'm probably going to have to just also break it up so that you guys can actually see maybe segments of it on my TikTok page. I'm just gonna make sure that I dissect it and then take certain segments and post them on, especially those that relate to translation. Okay, so let's go on here. Reflect triangle ABC about the y-axis. When we say reflect about the y-axis, according to what I explained earlier on, what did I say it means when we reflect about the y-axis? It simply means we are going to change what? We're going to change y. No, guys, we're not going to change y. We're going to change x, okay? X, the sign of x is going to change. So this is a matter of going and writing the new image for the translation about the y-axis. And let's see. We had -3 and 5. So what did we say? We are going to change what? X needs to change. Y, on the other hand, stays the same. Reflection about the y-axis means that x changes, but y stays the same. So -3 becomes 3. But you know what? The 5 stays the same. Let's look at the B image. Who changes? X to what? It was -6. Now we're going to write it as +6. What about y? Y stays the same. Let's look at the C image. -2 and 3. Who changes? -2 changes. His sign changes. To what? To 2. And then y stays the same. Okay. So as you can see, -3 and 5, reflection in the y-axis has led us to writing the new image of A as 3, +3 this time round, and the 5 has stayed the same. What about B? We had -6 and 3, but reflection along the y-axis means -6 changes to +6. But what about y? Y stays the same. Then last but not least, the image of C, -2 and 3, the new image, x changed to +2, but the y stayed the same. Does that make sense, guys? So now the only reason why I am saying here reflect about triangle ABC and I'm using the original A, B, and C is because in the question they did not say reflect maybe the image of triangle ABC in the previous question, or they did not give me an indication that they want me to change this already changed triangle. I hope that makes sense. So that's why we look at the question, okay, that we've been given. So let's go ahead. Now that we have the coordinates, we just plot. Plot in the new what? We plot in the new Cartesian plane because they want to see the reflection of triangle ABC about the y-axis. And we established that reflection about the y-axis simply means what? It simply means we change x, so which was once -3, x is now 3, but y stays the same. X, who was once -6, changes to +6. X, that was once -2, changes into +2. Then what about y? Y stays the same because we're reflecting about the y-axis. Let's go. Just plot the points. 3 and 5. Where's 3 and 5? 3 is here. Where's 5? Y for 5. Y for 5 is here. Where do they meet? They meet exactly there. So that is A, the new image, 3 and 5. B, 6 and 3. Where is X? Here. 6 is here. 3 for our beautiful Y. Y for 3 is here. Where do they meet? They meet exactly here. Then last but not least, C. C, X is 2. X is 2. Y is 3. Y is 3. That's here. Where do we meet? We meet here. So that's A, B, C. Then we just connect, 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 in the bag. Okay, in the bag. Reflection. If you look at this image here and you look at that image there, those are clearly this is clearly along this line, along the y-axis. This image and this image are clearly mirror images of each other. Okay, and yes, please, yes, Kiva, you do apply, you do actually plot, okay, the new points. Very important. Sorry about that. That was miss. Yeah, please do so in pencil. Do so in pencil, and remember, even the sketches, you sketch them in pencil. I don't have a pencil with me, but sketch in pencil and make sure you draw in pencil and you write the points in pencil. But yeah, I think one thing as well is that your teacher will see very clearly that your x value is 1, for instance, here, and your y value is -4 here. I mean, yeah, well, so yeah, please make sure you ensure that you put those points next to the relevant letters. Very, very critical that you do that. Thank you so much. That was wow, I like that. I like the fact that the student actually brought this to my attention. That says you are quite the student. I don't know if it's Kia. It's Kia, eh? Kia, thank you so much. That was actually, that's a brilliant yeah. Brilliant. That you actually identified that. It's very key. Very, very key. Guys, also, if you plot them incorrect, everything is wrong. Well, I guess it will depend on the particular memo and it's in the examiner. But you know what? Please just make sure you get everything right. Please, guys. Okay, get everything right, because yeah, you don't want to be butchering this, you know. Yeah, it's all in or all out. So let's be all in. Yeah. Mokamo, so you need to calm down. My goodness, calm down. Calm down, please. Okay, 5.1, calculate the perimeter of the diagram below. Okay, I'm actually pressed for time, guys. I'm pressed, very pressed for time. I'm pressed. The time is coming where I actually need to varmos and lead view, guys, you know, and there's quite a bit to cover still. Like, we have volume, surface area here, total surface area. So it's really popping and flowing and all sorts of things. Just let's go. Thank you so much for those. Thank you so much for those roses. I just want to check. Okay. I will do that. I'll definitely upload it. Yeah, I don't know if I actually have the memo for this paper. Doesn't seem like it. Don't seem like it. And it's just unfortunate as well that I don't have. Okay, I guess I'm gonna have to go live at 8 o'clock again. Okay, guys, for those who are like insisting that I do rotation and all of that, I'm gonna go live again at 8 o'clock. I'm just gonna have to push force matters here to happen, just for the purpose of rotation and whatever, rotation 90 degrees and all. If I do not go live, I'll definitely do a video for of explaining that for you guys. I promise you that I will not leave that hanging for you guys in the event that it does happen. I just want to kill this, and I need to finish this very quickly now because, yeah, time is pressing. Calculate the perimeter of the diagram. So perimeter, guys, I hope we all know what perimeter is. Perimeter is the total distance. Yes, 8 o'clock on the dot. Perimeter is the total distance around a two-dimensional shape, right? So if we look at this two-dimensional shape here, we have, it's like the person is running around this field, and if we want to know how much distance did this person run, that would be referred to as the perimeter of this shape. So 22 meters plus 15 plus 8, right? And now the thing is, you look at this, you're like, we are short of this distance, but we have the total distance here, which is 15. We have part distance here, which is 9, which is the same vertical plane. So what do we need? 9. If this was a complete, it's 15, 9. 9 plus what gives me 15, all right? So that means this is actually 6 meters, all right? The distance from here to here is 6 meters. Does that make sense? Okay, because this is 15 in total. That is 9. From here to here is 9. It means from here to here is also 9 in the same horizontal plane, if we were looking at this from this way. So that's also 9 meters from here to here. Okay, I hope that makes sense. So what we need then is the distance from here to here. We already have the total, it's 15. So that means 9 plus what gives you 15? That means we have 6 meters from here to here, because 9 plus 6 gives you 15. Are we together? So yeah, it's meters, guys, right? Because all of these are given as meters, not centimeters or millimeters. So 22, can we calculate the perimeter here? We need to make sure we have all the lengths for everything around, because length, perimeter means total distance around a two-dimensional shape. So we have 22, that's complete. We have 15 all the way down here, which is great. 8 all the way from here to there, which is great. But from here to here, we had nothing, remember? And we calculated that from here to here is 6. Why? Because from here to here is 15. We know that from here to here is 9, which is the same distance from here to there, which is also 9. So how much are we short to get 15? We need 6 more. So 6 meters is from here to here. Then we need from here all the way to here. What is the distance? So once again, from here to here is 22. From here to here is 8, which would mean from here to here is also 8 meters. What do we need to complete? 8 plus what gives me 22? That means this is 14 meters. Okay. Now, the minute I have all of those lengths, guys, then I'm good to go. Perimeter is total distance around an object. So all I'm going to do is I'm going to say perimeter is equal to, okay, my perimeter is equal to, after finding all of those sides and so forth, perimeter is equal to 22 meters plus 15 meters, 22 plus 15, plus 8 meters, plus 6 meters, okay, plus 14 meters, plus 9 meters, and then we are back to 22. So I do not obviously continue to add that 22. Does that make sense? Okay. So all in all, you add all of this, 22 plus 15 plus 8 plus 6 plus 14 plus 9. Now imagine if you didn't have this 6, then you cannot possibly get the perimeter of the shape. Imagine if you didn't have this 14 meters, then you can't possibly get the perimeter of the total shape. So what we need to put in our minds here is that when we talk about perimeter, we are talking about the total distance around that shape. And in order to get the total distance, you need to have all of your dimensions, all of them. They need to be covered, all bases. If I'm an athlete and I'm running around this track, let's say this is the track. Running around that track is what I call my perimeter. So from here to here, 22. From here to here, it's 15. From here to here is 8. From here to here, I had nothing. So I had to think about, what is the distance from here to here? Oh, I have a vertical total distance of 15. I have a sub distance of 9 meters. What is the distance from here to here completed? Then it must be 6 here, because 9 plus 6 gives me 15. Then from here to there, I have a total of 22 meters. But here I have a sub distance of 1 of 8 meters. What is short for me to get 22? From here to here, it must be 14 meters. Then after that, getting all the lengths means I can add all of the dimensions and get my answer. So I'm seeing people are saying the answer is 474 meters. Guys, please don't leave such questions begging, man. It's not square meters, remember, because perimeter is simply the distance around. I don't know if you've ever ran 100 meters. I'm sure some of you were watching the Olympics. And guys, when you're running from one point to another, I mean, we know that's a 100-meter race. I don't know if you guys have ever seen a 100-meter square race. We don't talk about a 100-meter square race because perimeter is simply the total distance around. So you are measuring distance. It can either be in centimeters, it can be in millimeters, it can be in kilometers, it can be in units. So please don't write 74 meters squared. If you write that, guys, then it means you are confusing two concepts together. This is 74 meters. We are measuring. It's like you measuring from here to here, from here to how much is it? All right? It is 74 meters. Are we together? I hope we are good. Like, it's very important for that. So two things: make sure you have all the dimensions around that shape, so that you can calculate the distance. And what I mean by dimensions is that you need to be able to have a starting point and check, do I have the distance all the way around, all the way back to where I started? Okay, that is perimeter. That's what we refer to as perimeter. Area, on the other hand, is different. Okay, because when we talk about area, we are talking about the space covered within a two-dimensional shape. All right, and that is measured in square units. All right, perimeter is the total distance around this shape. Okay, so this shape, from here to here, how much distance have we covered? 22. From here to here, how much distance have we covered? 15. So it's 22 plus 15. So far we are good. How much distance have we covered from here to here? It's a plus another 8. So we add another 8. How much distance do we cover from here to there? We don't know yet, because we didn't know, we were not given the distance from here to here. But can we find it out? Yes, because if we know from here to here is 15, and we know from here to here is 9, we have a full and a part distance. Then it means we can find from here to here, which is the same distance from here to here. 9 plus what gives you 15. So this is 6 meters. From here to here is 6 meters, the vertical distance. Then we have this horizontal distance, which we didn't know, but can we find it out? Yes, definitely we can. If this is 22 meters, then obviously we have a part distance of 8. 8 plus what gives us 22? It's 14 meters. Then you have all your distances. You can add them and get the answer. Okay, I'm going to come down to this two-dimensional shape, which I'm hoping you guys know what it is, right? I think someone actually did say, please go down to that shape there. There's like a form of music and dance. I think it's called trap music or trap dance or trap music, trap. But anyways, the nonsense I wrote in this paper. You guys are killing me with your comments. You guys kill me with your comments even in the videos that I post. You guys are so funny. It is so funny. Anyways, the quadrilateral below is a trapezium. Find the area and the perimeter of the diagram below. So we are told that this is a trapezium. So let's check this trapezium out. We have 11 centimeters. We have 9. We have 17. We have a perpendicular height of 8 centimeters. Okay. And then they are asking us to calculate the perimeter. Look at the spelling. Okay. It's typical maths teachers. We don't know how to spell. But anyways, you forgive us, right? Because this is not an English paper. But nonetheless, it does not justify the nonsense, right? Okay. A quadrilateral below is a trapezium. Find the area and the perimeter of the diagram below. Now, first and foremost, perimeter. Total distance around the trapezium. Quick question. Do we know the total distance around? Do we have all the dimensions? That is the $1 million question. This side is 11. This side is 17. This one is 9 centimeters. It is at an angle of some sort. All right. But the question is, do we have this side because in order to find the total distance around this trapezium, we need to have this side as well, so that when we add these different sides, we can be able to find them. So we obviously evidently don't, and we cannot assume. That's another thing, because if we hey guys, if we assume, then it's problems. Okay, very big problems. Okay, what's happening here? Seems like some comments there. Yeah, guys, we need to defer from comments that are, inappropriate. Let's do that as much as possible. I think, let me do this quickly. I think kind of know how we can quickly. I think I need to make sure that I put some phenomenal restrictions. Let's do this. I think this person deserves. Okay. I think I've just given someone moderator status so that they can help me out with the comment section as well. Okay. All right. So here we are. So, how then? The question: how then do we find the missing? Because we want to find. We need to find, guys. We need to find this missing side. Okay. Yeah, the other side is 9 centimeters, but we cannot assume. They didn't tell us that this is it's one of those equilateral quadrilaterals. I mean trapeziums, because there's such a thing called an equilateral trapezium, where these two sides are actually equal. But in this case, we were not told anything. And then the question is, have we been given information in this diagram sufficient that we can be able to find out what that side is? That's another question, right? So very quickly, let's just do this. But the sides are equal, aren't they? Are you sure they're equal? Who said they are? We're not told that they are equal. Okay, can we assume that they are equal? Cool. This is 17 centimeters. Okay, that's 17. Very nice, 17 centimeters. That is 11. So what's 17 centimeters minus 11 centimeters? There's something interesting here that I just want you guys to note. I'm guessing, yeah, we can assume that. Okay, so if we were to actually just inscribe this in, this is 11 centimeters. From here to here is also 11, right? And then from here to there, all right. Yeah, the assumption, I think, guys, it would be safe to say that, because, and unfortunately, I personally just believe that the diagram, whenever you have a diagram that is actually given by people, I mean, you need to give sufficient information in the statement so that it can lead. Because what I'm looking at, for instance, is the mark allocation, and the mark allocation here is 2 marks. And to have to use Pythagoras to go and find the missing side is basically not within the realm of that. So what they would have had to have done in a paper, when they give it to you, they must ensure that they give you adequate information so that you can be able to go ahead. So here, in the absence of adequate information, okay, I'm gonna assume that they basically were supposed to have said that this is an equilateral trapezium, because such does exist. Okay, and they should, right? Because even if, let's say, we are going to go ahead and use Pythagoras to be able to find, right, the other thing that we are going to strongly assume here is that the residual length for the base here is 6 in total, but then that would mean we allocate 3 centimeters and 3 centimeters. Why would we allocate 3 centimeters and 3 centimeters? Because our assumption is that this is a equilateral trapezium. So we haven't been given enough info, guys, not enough info. So what I would then suggest is that this is an equilateral trapezium. seeing as though that's the case, then this is 9 centimeters. Okay, on that basis. All right, because everything else that we are going to do based on assumption, and it's not good to assume. So I would say personally, they did not give us enough information, and even to actually look at this and make those conclusions is not enough. So that's 9 centimeters. So what we do is we're simply going to add all those sides. 9 plus 9, which is 18, plus 11, all right, which is 29, and 29 plus 17 will give us a nice answer of 46 centimeters. So that's 46 centimeters. And then lastly, what they want us to find is the area of the particular shape. So the area of this shape, I'm sure you guys can see that, yeah, so if it's an equilateral, then that means that's 3 centimeters. That is 3 centimeters. It's chi, guys. It's chi. We have 2 right angle triangles and 1 rectangle. 2 right angle triangles and 1 rectangle. Does that make sense? 2 right angle triangles and 1 rectangle. Now you guys should know that the area of a triangle is given by the formula area is equal to half base times height. You should know that by now. Okay, and then the area of a rectangle is given by the formula length times breadth. Are we together? Now if we take these 2 triangles, we're gonna say area of the 2 triangles plus the area of the 1 rectangle. Okay, this is 1 rectangle and the rectangle. Okay, so 2 triangles, 2 half base times height plus 1 length times breadth. That's basically what it is. 2 half base times height, meaning 2 triangles. Okay, where's 46 from? For the person who basically doesn't understand why we said the perimeter is 46 centimeters, this we've basically taken is a equilateral trapezium, which means these 2 sides are equal. So if that's 9 centimeters, that's also 9 centimeters. Then on top of that, you add the 11 centimeters and you add the 17 centimeters. From here to here, 11. To here, plus 9. From here to here, plus 17. From here to here, plus 9. Okay. Then back here again, go. Okay, sorry about that. Yo. Okay, all right. So yes, you add all of these 4 sides for a perimeter. 11 plus 9 plus 17 plus 9. That's where we got the 46 centimeters. We simply added the dimensions, all 4 of them together. Okay. I'm sorry. I wish I could speak Afrikaans. I can't Afrikaans praat because not so, you know. Okay, then 2 triangles. Like I said, so now to calculate the area of the the area of the trapezium. Okay, so to calculate the area of the trapezium, you could use this, but it's not necessary, right? I was just pointing that out, that remember I said to you that the area for any shape is actually the space covered within a 2-dimensional shape. So all you want to do is you want to calculate in square meters how much space has been covered within the 2-dimensional shape. But Tina, we have easy access. We know that the area of a trapezium is given simply by half the sum of the parallel sides times the perpendicular height. That's it. So it's half times the sum of the two parallel sides times the perpendicular height. That's it. Done and dusted. Times the perpendicular height. The sum of the parallel sides. Now we're going to go back here. Which are the parallel sides? It's 11 centimeters and 17 centimeters. So we simply just say half times the sum of the parallel sides is 17 plus 11 times the perpendicular height. Have you been given the perpendicular height? Yes, we've been given the perpendicular height. It's 8. Then you simply put all of this in your calculator. Half times 28 times 8. I mean, you could just put this in your calculator, guys, and just get it. Okay, so it's 112 what? Centimeters. Centimeters what? Squared. And this is very important. You can put square units now because we are calculating area, not perimeter. Okay, and please, people, this is what distinguishes area from perimeter. Area is given in square meters, right? Very important. All right, I hope this is somewhat clarity for some. Okay, yes, Ratile, I can see you laughing big time there. But imagine if you go in with that perception and it's clear for you that area is in square units, whereas perimeter is just in units, then you should be fine. Okay, yeah. I did congruency and similarity earlier on. Okay, I'll be back here at 8 o'clock. So if you want to catch me live again, rehashing some of the things, please catch me then. I'll also be uploading this video onto my YouTube channel for the purpose of those who want to check it out. Please. How is 17 centimeters parallel to 11 centimeters? That's very funny that you asked that question. I'm guessing in your head you are believing that. Remember, for a trapezium has one pair of opposite sides that are parallel. Parallel does not mean equal. I think some people have that misconception of thinking that parallel sides mean these sides are equal. No, parallel lines are lines that never meet. Okay, they never meet. It's like a boy and girl that are in high school. They fall madly in love with each other, but you know what? Because of education, they decide not to engage or become or enter into a relationship. Why? Because their relationship with their school books is more important right now, and that investment will be that investment that will lead to a person's independence. Without that independence, I mean, how in the world will you be able to get to a place where you can actually seriously think of something serious in the future? And I mean marriage by that. So parallel lines, they never meet. Parallel lines are not equal per se. Parallel lines are just lines that never meet. Okay, YouTube channel is called Maths is a Game. You can go onto the page and you can go onto the icon, that the YouTube icon, and you can click on that. It will send you directly to the YouTube channel. So after this live, I'm actually going to download the live video and send it to the platform so that guys can check it out. But like I said, 8 p.m. I'll be going live again because it seems like it's popular demand. People want me on, so I'll be back here. Hopefully TikTok doesn't ban me because it's been doing that lately. They say I'm gambling. I don't know how I'm gambling by teaching. But anyways, the perimeter of a rectangle is 46 centimeters. If the length is equal to 2x plus 5 centimeters and the breadth is equal to x plus 6 centimeters, calculate the area of the rectangle. This is very important. The perimeter of a rectangle is 46. If its length is 2x plus 5 and the breadth is x plus 6, calculate the area of the rectangle. Okay, so let's do this first and foremost. Look at what's given. The perimeter of a rectangle is 46, meaning P is equal to 46 centimeters. Its length we are given 2x plus 5. 2x plus 5 what? Centimeters. And the breadth is equal to x plus 6 centimeters. So what are we being asked here? We are actually being asked to calculate the area of the rectangle. But before we do that, right? Before we do that, we know what the formula for perimeter is for a rectangle. Okay? And we know a rectangle's perimeter is simply what? 2 length plus breadth. That's what it is. 2 length plus breadth. Okay? 2 brackets length plus breadth. That is the perimeter formula for a rectangle. Okay? You have 2 lengths that are the same. So it's like length plus length plus 2 breadths plus breadth plus breadth. So that's like 2 lengths plus 2 breadths, if you understand it that way. So we know that the perimeter formula is that, and we are told that the perimeter is what? 46 centimeters. They want us to calculate the actual area of the rectangle. Not in terms of x, but they want us to calculate the actual area. So it's very straightforward. What we do is we're going to use this formula, 2 length plus breadth. Okay. And then what is the perimeter? It's 46. 2 length plus breadth. Remember, the length is 2x plus 5. We substitute. Plus the breadth is x plus 6. What are we doing this for? We want to be able to solve for x, so that by doing that, we can find the value of x. And after doing so, we can actually go ahead and calculate what the area is. So in the brackets, we have 2x plus x, which is 3x, and 5 plus 6, which is 11. We distribute the 2, we get 6x plus 22. Remember, we distribute that 2 is equal to 46. Then 6x plus 22. 6x is equal to, we transpose the 22, we have 46 minus 22. And then that's 6x. What's 46 minus 22, guys? Do we know? 46 minus 22. How come at 8? I'm so lost. Yeah, if you caught this halfway or midway, guys, yeah, it's very hard to be found. Then we divide both sides by what? By 6. We get a nice answer, which is x is equal to what? 4. Okay. Now, since the answer of x is 4, we can go back to the length and get the actual values of the length. The length was 2x plus 5. 2 into 4 plus 5. The breadth was x plus 6, meaning 4 plus 6. So the actual lengths are actually 8 plus 5, which is 13. So we have a length of 13 centimeters. And then the breadth is 10 centimeters. Can you now calculate the area? Yes, we can. Area of a rectangle, area is equal to length times breadth, right? And all we do is we take this length that we found. Remember, how did we find the actual length? We took x is equal to 4, went back to our expression for the length, substituted the x is equal to 4 in the place of x for 2x plus 5. Now what we have is 2 times 4 plus 5. What's 2 times 4? It's 8. Plus 5 is 13. So the length is 13. Then for the breadth, we have x plus 6 centimeters, which represents the breadth. So we take the x is equal to 4, substitute it in the place of x. We get 4 plus 6, which is 10. Now we can calculate the length times breadth, which is 13 times 10, which gives you 130 what? Centimeters. What? Squared. That is the area. Okay, don't forget the squared. Without the squared, then you're not talking about area anymore. It's like you're talking about something else. So make sure. Now check this out. Calculate 1,12 kilometers squared is equal to in meters squared. Now something I just want to quickly show you guys. Maybe you may not know, but you're supposed to know. This is what I call the conversion. My conversion units. You are so fast. I know I'm so fast. It's not even funny. Fast like the speed of light. I'm trying to finish up, guys, because if I'm going to come back at 8 o'clock live, then there's things that I need to go and take care of. Otherwise, I won't have time to take care of those things, and then I won't be able to come back here, So I'm sorry. You guys are just meeting me when I am really trying to push until I can finish. So we have this thing here, kilometers to meters. If you want to convert kilometers to meters, you times by 1,000. Meters to centimeters, you times by 100. Centimeters to millimeters, you times by 10. Then vice versa. Millimeters to centimeters, you divide by 10. Centimeters to meters, you divide by 100. Meters to kilometers, you divide by 1,000. So this is a helpful conversion thing. Now, if you want to convert millimeters all the way back to meters, then you're going to have to first divide by 10, then divide by 100. Or you can just divide by 1,000 straight on, because this 0 you would add there so that you can be able to get this unit. So you first divide by 10, then you divide by 100, you are in meter stage. So it's nice to have this thing just as something available to utilize. Then for areas as well, I like having the areas one as well. Kilometers squared to meters squared, you multiply by 1,000,000. Meter squared to centimeter squared, you multiply by 10,000. Centimeter squared to millimeter squared, you times by 100. Okay, yeah, and vice versa. Okay. Oh, fast sham. Who told me? That is so funny. Oh, fast sham. I can just see you saying that. Oh, okay. Is that the shared consensus, guys? Can I just kill this live so that I can take care of stuff and let's just come back at 8 o'clock? Do we all agree? Because if that's the case, then I'll definitely do that. We'll come back on 8 o'clock again and we can have this. Kokenzo is saying yes, yes, yes. Seems like everybody's on a yes. Yeehaw! Prudence is like, no! Steve was like, sharp, sharp. No, finish the first question, please. Okay, I'll at least finish this one, Kevin. This one that I was doing. 5.4. This one. 1,12 kilometers squared is equal to. So if we go back to the conversion table, we're supposed to convert kilometers squared to meters squared. So what are we going to do to this 1,12? We're just going to multiply it by 1,000,000. And then we're going to get our conversion to meters squared. Because remember, this is area conversion. So for my area conversion, I have this nice conversion table that I usually utilize. And I always remember it, that kilometer squared to meter squared, I just multiply by 1,000,000. Meter squared to centimeter squared, multiply by 10,000. Centimeter squared to millimeter squared, I multiply by 100. And then vice versa. You divide by 100 millimeter squared to centimeter squared, you divide by 10,000 centimeters squared to meter squared, you divide by 1,000,000 from meter squared to kilometer squared. Also, this one is just for your units, yabo? Kilometers to meters to centimeters to millimeters. You times by 1,000 for the first one, you times by 100 from meters to centimeters, you times by 10 from centimeters to millimeters. All of these ones, guys, should be pretty straightforward. If you're going to calculate the surface area for this rectangular box, it says it's a carton that is the shape of a rectangular prism, 30 centimeters long, 20 centimeters wide, and 10 centimeters high. Calculate the surface area of the carton. This carton. Alright, guys. Volume. I'm sorry, it's not volume here. The surface area. Then, yeah, guys, you should be able to do this one quite comfortably because I'm assuming you all know that there are 6 faces of this rectangular prism. You know? Yeah, which is very important. Okay. 5.4. Oh, you want me to write down the answer? So the answer is, what is it? If you times this by 1,000,000, if you times this kilometer squared by 1,000,000, what do you get? Let's see. 1. Thank you. Thank you. 120,000 million. Yes, thank you. Thank you so much, guys. Thank you so much. But I will come back later on, okay? Because yeah, it was just now the rectangular prism, okay, for 3 marks, and then it was the cylinder question. Your cylinder has a radius of 7 centimeters and a height of 10. Calculate the volume. Okay, so all I'm gonna do is I'm just gonna write. I'm not gonna actually calculate the surface area of this Landoga, but you guys should know it's 2 length breadth plus 2 length times height plus 2 breadth times height. Remember, this is your breadth. No, sorry. This is your, yes, this is your breadth. Actually, sorry. We refer to this as the height. We refer to this as the length. We refer to this as the breadth. So this is the height, 10 centimeters. This is the length. This is the breadth. If you want to calculate the total surface area, remember there are 6 rectangular shapes basically. 1, 2, 2, front and back 2, top and bottom 2, and then side and side 2. All right, so these are there. And then last but not least, I mean obviously you'd substitute into that formula and get the answer. Then the volume of a cylinder is given by the area of the base, which is the circle, times its perpendicular height. All right, so you've given the radius and you're given the height. And they're actually saying here that if pi is equal to 3,14, so that is the assumption that you use this value. You use the rational value of pi to basically calculate and get your answer, not the one in the calculator, because they say calculate the volume of the cylinder if pi is equal to 3,14. So you stick to this, guys. You stick to that. Total surface area for the cylinder. Total surface area would be equal to 2 pi r squared plus 2 pi r h. Yeah. 2 pi r squared plus 2 pi r h. That is the formula for calculating the surface area of the cylinder. Okay. Yeah. And then last but not least, if dimensions are doubled, what would the total surface area be? Remember, if dimensions are doubled, meaning you are doubling everything. In other words, you're going to double your radius, you're going to double your height. That's all. It just means you're going to say times 2 to the radius, which is your new radius will be 14 centimeters. And you're going to double the height, which means 10 times 2 is going to be 20 centimeters. And all they are asking here, if the dimensions are doubled, what would the total surface area be? So you just use the same formula, guys, and all you are doing is you're substituting the new values, right? And then you check what the new surface area is. If the cylinder is open, remember, for surface area, right, we talk about the two circles, the top circle and the bottom circle. If one of the surfaces of your circle are open, then it means you no longer have two circles, but you have one. So here, this formula would be affected in that it will no longer be 2, but it will be 1. Okay, but if they say both surfaces for your circle are open, then it means you do not have two circles anymore that are enclosed. Okay, but like I said, guys, I think I will leave it right there. Okay, I will now go way. I will leave now, guys, and yeah, go and refresh and do other things as well, and then I'll be back here at 8 o'clock. Guys, I mean, the time though is just, it's gonna go by too fast. Guys, want me back here at 8 o'clock, it's gonna be now. If I decide to go back a bit earlier because I finished things earlier, then sorry for you. Okay, and the reason I was going fast is because, guys, I need to leave. Okay, at the beginning I was going very nicely, very nice pace, but you know, as time went by, you guys, yeah, too much love. Thank you so much for your love, really appreciate it. I will be seeing you at 8 o'clock. I will spend some time now downloading the video as I do other things, and then as soon as it finishes to download, I will post it onto the YouTube channel. Those who want to know what's up with the YouTube channel, please just go onto my main page on my bio, go to the YouTube icon, press on the YouTube icon. It will take you to a YouTube channel called Maths is a Game. Thank you so much, Puseleto5, for your sweet rose. I really appreciate it. It will take you there to my YouTube channel. It's called Maths is a Game. So everything is Maths is a Game, guys, because Maths is a game, right? You learn the rules, you play it long enough, you play it often enough, and soon what do you realize? Hey, the game is easy. I can kill it. And then level 7 is just nothing. I love it when my learners, like for instance at school, get to a point where they're like, sir, this thing is easy. And it's like the more time I spend doing it, the easier it gets. And level 7 and even 100% is just it's a norm, you know. That is something that can possibly happen, but you need to, like I said, spend time playing the game. And yeah, learning the rules, meaning you need to know the concepts, you need to know the ins and outs and everything like that. Okay, no, I will not forget, man. 8 o'clock, guys. Like I said, if anything happens at 8 o'clock, it will be because, like I said, I'm a family man and there are things that ought to be done. But I'll be uploading this and now in the YouTube channel as soon as I am able to do it. Yeah, so take care, guys. Love you lots. Thank you so much. You guys have been great sports. I really appreciate it. I won't forget to upload it. You guys are amazing. Good night. Oh man.